Today we'll be learning how to factor by grouping. So we're going to approach factoring by looking at the number of terms that the polynomial has. We're going to start today with factoring a 4-term polynomial. Factoring by grouping is also called factoring in pairs. And the grouping method is used when the polynomial has 4 terms. So we are going to be splitting the 4 terms into 2 pairs. For the steps, we're always going to start with checking for a greatest common factor. Before we do anything, always check to see if all 4 terms have a greatest common factor. With the exception of 1. It's always going to have 1 in common. If it has something other than 1, we're going to check for that. So step 1 should actually be check for the greatest common factor. So we have here a 1 as the leading term here, leading coefficient. 7, 2, and 14. And there is no greatest common factor or no common factor for those 4 terms except for 1. So we don't need to worry about a GCF for this one. We're going to group the first 2 terms together and the last 2 terms together. So I just like to draw a little line here right in front of that sign in front of the 3rd term to split the two pairs. So now we're just going to find a greatest common factor for the first 2 terms. So we're just looking at x cubed and 7x squared. So we don't need to factor out a number because 1 and 7 don't have a greatest common factor. So we can take the lower exponent of x to factor out. So we're going to factor out x squared. So remember, when we factor that out, we're going to move it to the outside of parentheses and then divide. So what's left after we divide x cubed divided by x squared is just x. And then x squared divided by x squared cancels out. So we have just plus 7. I'm actually going to put this in a different color here. X plus 7. Okay, so now we can look at the second pair. And we are going to look for a greatest common factor for 2 and 14. Well, 2 and 14 have a greatest common factor of 2. So we are going to write plus 2 because it's a positive 2 and a parentheses. Now we divide again. 2 divided by 2 is 1, so that cancels out. So now we just bring down x. 14 divided by 2 is positive 7. Now if you've done this correctly, you will have 2 sets of parentheses with the same binomial inside. We have x plus 7 and x plus 7. So now we're going to factor out the binomial as a common factor. So we're going to move that over here to its own set of parentheses. And I just like to kind of cross it out up here to be able to see clearly what is left. And what is left goes in the second set of parentheses, x squared plus 2. So now I have factored this polynomial into 2 binomials. And I'm going to show you some tricks that will help speed up this process. So we're going to factor each polynomial by grouping. So we're going to look at the 4 terms, see if there is a numeric GCF for all 4 terms, and there isn't. So 1, -5, -2, and 10, they don't have a greatest common factor. So let's split this into 2 pairs. The greatest common factor for xy and -5y is just y. That's what they have in common. So we're going to factor out y and divide. So y is going to cancel out. So we're left with just x, and then y cancels out here, minus 5. Now here's where I'm going to show you a shortcut. Look for the greatest common factor for negative 2 and 10. If that first term is negative, you have to factor out a negative. This will help you always remember to factor out the negative. You're going to take this last term, 10, divided by this term, negative 5. 10 divided by negative 5 is negative 2. Negative 2 is the greatest common factor for negative 2 and 10. So we will write that down here, negative 2, and then divide. So negative 2x divided by negative 2, the negative 2 will cancel out, so we have just x. And then 10 divided by negative 2 is negative 5. So that little division trick just helps you to find this term here. If you have a harder time finding the greatest common factor, or sometimes you forget to factor out the negative, that will always work if you divide that last term by the term here. Okay, so now we have matching binomials. We have x minus 5 and x minus 5, so we're going to put that in its own set of parentheses. And then in the second set of parentheses, what is left is y minus 2. Number 3, look for greatest common factor. We have 1, 5, negative 8, and negative 40. They do not have a greatest common factor for all 4, so we're going to split them into 2 pairs. The first pair has the greatest common factor of x squared, the lower exponent. Now I divide. 3 minus 2 is 1, so we have just x. And then x squared divided by x squared cancels out, and we're left with just plus 5. Now again, let's figure out what to factor out on the right side and use the trick of negative 40 divided by 5. Negative 40 divided by 5 is negative 8, so I'm going to factor out negative 8 here. So subtract 8, and then divide. Negative 8x divided by negative 8, the negative 8 cancels, and I'm left with just x. Negative 40 divided by negative 8 is positive 5. So I have matching binomials, x plus 5 and x plus 5. So I have x plus 5, and then x squared minus 8. Okay. Number 4, look for a greatest common factor. We have 8, 12, 2, and 3, and they don't all have a letter in common. 3 of them have x's, 2 of them have y's, but there's nothing that all 4 of them have in common, so we will move to splitting them into 2 pairs. The greatest common factor for 8 and 12 is 4, so I know there's going to be a 4 in my factored out term. And then x with the lowest exponent is x to the power of 1, or just x. So that's what I'm going to factor out. 8 divided by 4 is 2. X squared divided by x is x. 12 divided by 4 is positive 3, and then the x's cancel out. Now again, let's divide 3 divided by 3, or sorry, 3y divided by 3 is just y. Okay, so y is going to be what I factor out on the right. So 2xy divided by y, just the y's cancel out. Oh, I forgot to write plus y here. Plus y. The y's cancel out, and so I'm left with 2x. And then the y's cancel out here, plus 3. I have 2x plus 3 and 2x plus 3. And then I'm left with 4x plus y. Okay, number 5. Again, no greatest common factor for all of the terms. So let's factor by grouping. They do not have a number in common, but they both have c squared. So I'm going to factor out c squared. So c squared d divided by c squared, the c squared will cancel out, and I'm left with just d. 3c squared divided by c squared, those cancel out, so I have plus 3. Now, again, let's divide negative 21d divided by this 3. So that equals negative 7d. So that's what I'm going to factor out here. Negative 7d. Remember, if this here is negative, you have to have a negative in your greatest common factor on this side. So negative 7 cancels out, and d squared divided by d is d. Negative 21 divided by negative 7 is positive 3, and the d cancels out. So now we have d plus 3, d plus 3. If those don't match, you need to go back and figure out where you went wrong, because those have to match. So now we have c squared minus 7d. Okay, let's look at some examples that do have a greatest common factor, so you see what we need to do with that when we factor it out in the beginning. So looking at number 6, 4, negative 16, 2, and negative 8 all have a greatest common factor of 2. I can divide all of those by 2 evenly. So I'm going to factor out 2 from each term. Move 2 to the outside of the parentheses and divide. So now I have 4 divided by 2 is 2, ab squared. Negative 16 divided by 2 is negative 8, b squared. 2 divided by 2 is 1, a. And negative 8 divided by 2 is negative 4. So now that I factored out the greatest common factor, I can now factor by grouping. We just have to remember that there is a 2. We have to make sure we keep that 2 and bring it down to the final answer. So let's find a greatest common factor for 2ab squared and negative 8b squared. So for 2 and negative 8, I can factor out 2. They don't both have an a, but they both have b squared. So I'm going to remember to bring this down with each step. So now I have 2b squared. 2 divided by 2 is 1. B squared and b squared are going to cancel out, so I'm going to be left with just a. Negative 8 divided by 2 is negative 4, and then b squared divided by b squared is going to cancel. This will still work now. Negative 4 divided by negative 4. That's 1. So I'm just going to factor out a 1 here. So plus 1. If that is positive, remember to put a plus sign. And then anything divided by 1 is itself, so I'm just going to write a minus 4. So let me bring down the 2 again. 2. I'll factor out this binomial, a minus 4. And then 2b squared plus 1. So if I factored out 2 in the beginning and I forgot to bring it down to the final answer, the answer would be wrong. There has to be the 2 there. Okay, number 7. Let's find a greatest common factor for 6, 15, 12, negative 12, and negative 30. I can see that the greatest common factor for all 4 of those is 3. So I will factor out 3 from each term. 6 divided by 3 is 2, n cubed. 15 divided by 3 is 5, n squared. Negative 12 divided by 3 is negative 4, n. Negative 30 divided by 3 is negative 10. Now I can factor by grouping. So I will look for a greatest common factor for 2n cubed and 5n squared. 2 and 5 do not have a greatest common factor, so I'll factor out n squared, the lower exponent. So remember, I've got to bring down 3, and now we'll bring n squared outside the parentheses. So 2 divided by 1 is 2. N cubed divided by n squared is n. 5n squared divided by n squared, these cancel out, so I have just plus 5. Now let's divide. Negative 10 divided by 5. That is negative 2, so I'll be factoring out negative 2 here. Minus 2, parentheses. Negative 4 divided by negative 2 is positive 2. Bring down n. Negative 10 divided by negative 2 is positive 5. We have matching binomials. So I'll bring down 3, factor out the binomial, 2n plus 5. And then what is left is n squared minus 2. Okay, let's look at a couple of examples where you can see that you might be able to factor by grouping if these were in a different order. You can change the order of a polynomial. The most important thing to remember is you have to keep the sign that's in front of it. That's what you cannot change. So let's look at number 8. We have x squared plus 2xy minus 5x minus 10y. Now, I can see that these 3 have x, and these 2 have y. And if I'm going to factor by grouping, it would make more sense if I switched these middle 2 terms, because then I would have 2 x's on the left and then 2 y's on the right. So let's rewrite this as x squared minus 5x, because the minus stays with the 5, plus 2xy minus 10y. Now factor by grouping. These 2 have in common x. X squared divided by x is x. These x's cancel, and I have minus 5. On the right, we're going to take negative 10y divided by negative 5, which is positive 2y. So divide by 2y. So the 2 cancels out, the y cancels out. I'm left with just x. Negative 10 divided by 2 is negative 5, and the y cancels out. So now I have x minus 5 and x plus 2y. Okay, let's look at number 9. 10ab plus 21 minus 15a minus 14b. Now I can see 2 different reasons to rearrange these. The first one is that these two have a's, so that's what they have in common. But another thing is that 10 and 15 are easily divided by 5, and then 21 and 14 have 7 in common. So it would be really good to switch these middle 2 terms before I try to factor. So 10ab minus 15a plus 21 minus 14b. So now let's factor by grouping. So 10ab and negative 15a have 5a in common. So 5a. So this will be 2b. And then negative 15 divided by 5 is negative 3, and the a cancels out. Okay, now I'm looking at this, and I want the binomial that's going to match this one. Oops. So I would like for the b term to be on the left, not on the right here. Because when I divide, if I end up with a b on the right, then they're not going to match. So let's go ahead and switch these two now. So instead of plus 21 minus 14b, let's do minus 14b plus 21. So now let's take 21 divided by negative 3, that's negative 7. So minus 7. Negative 14 divided by negative 7 is positive 2b. 21 divided by negative 7 is negative 3. So you see now I have perfectly matching binomials. So factor that out. 2b minus 3 times 5a minus 7. One more. Okay, now remember we have to check for a greatest common factor first. They don't all have m's or n's, but they're all even. So I believe I can factor out a greatest common factor of 2. So let's go ahead and do that. This leaves me with 12m squared plus 28mn plus 3m plus 7n. Okay, so I've factored out the greatest common factor. Now let's look at these. I think I would like to put this one with an n over by this one with an n. So I'm going to switch these two. So let me rewrite this. 12m squared plus 3m plus 28mn plus 7n. Now factor by grouping. 12 and 3, the greatest common factor is 3, and then the lower exponent is 1 for m. So 2 and then we have 3m factored out. 12m squared divided by 3m is 4m. And then 3m divided by 3m, they both cancel out, so that's plus 1. Okay, and then let's do our trick here. 7n divided by 1 is 7n. So that's what I'm going to factor out on the right. 7n. So plus 7n, that's 4, and the n's cancel out, so 4m, and then 7 and n both cancel, so that's plus 1. So now, my final answer, factor out the binomial, 4m plus 1, don't forget to bring that 2 down, times 3m plus 7n. So that is factoring by grouping.